Okay, can continue.
Molar mass of A. Let's calculate the molar mass of A first. Molar mass of A, and A is HNO3. This will give us 1 plus 14 plus 16 times 3. This will give us 1 plus 14 plus 48. That will give us 63 gram per mole. Which means that come in mole per dm³ of A will now be equal to mass of A, which is given from the equation 3.15 over 63 multiplied by 1000 cm³ all over volume 500 cm³. If you divide 3.15 by 63, you have 0.05. Then multiply by 1000 divided by 500, you have 2. Then 0.05 times 2, that will give us 0.1. Because concentration must always be approximated to 3 significant figures, you add 2 zeros to make up the figures. This will be 0.100 mole per dm³. Mole per dm³. This is question number BI. Then BII. BII says calculate the concentration of Na2CO3 in B in mole per dm³. II. Concentration of Na2CO3 in B, still in mole per dm³. Since you have gotten the concentration of A in mole per dm³, here we're going to use the general formula. Before then, you have to, first thing is to get your equation of reaction. When you remember that it is only Na2CO3 out of the mixture that reacted with the acid, which means the acid given to us is HNO3 in aqueous plus Na2CO3, which is the component of the mixture that reacted, and that will give us NaNO3 in aqueous plus water in liquid state, then plus CO2 in gaseous state. To balance the equation, sodium is 2 at the reactant side, and at the product side, make sodium 2. Hydrogen is 2 at the reactant side, bring 2 here to balance hydrogen. We have 2 hydrogen at the reactant side, nitrogen 2. Oxygen is 6 plus 3, that's 9. 6 plus 1 is 7 plus 2 is 9. It's balanced. So using CaVa all over CbVb will now be equal to Na all over what? Nb. Our Ca is already known as what? 0.100 multiplied by our Va, which is the what? Average volume of acid used, which is 25.73 all over Cb, which is not given, multiplied by our Vb. Vb is the volume of pipettes used, that's 25.00. We now be equals to number of moles of the acid from the stoichiometry of reaction or the balanced chemical equation is 2. Number of moles of the base here is what? 1. It means that our CB will now be equals to 0.100 times 25.73 multiplied by what? 1. If you cross multiply, all over 25.00 times what? 2. Punch your calculator direct, then you get an answer that our CB will now be equals to, engage your calculator. 0.0517. The unit must always be mole per dm3. Mole per dm3. Question number 3. VIII. Concentration of Na2CO3 in B in mole per dm3. VIII. Concentration of Na2CO3 in B, also in mole per dm3.
Sir,
Yes.
this is 0.205.
This
0.0515, not 7.
515, not 7.
Yes.
What you gave to me is what I wrote. Okay. Concentration of Na2CO3 in B in mole per dm3. You recall that this time around is in gram per dm3. That is III. We recall that conc in gram per dm3 of Na2CO3 will now be equals to conc in mole per dm3 of Na2CO3 multiplied by molar mass of Na2CO3. From the way we have already calculated conc in mole per dm3 of Na2CO3. Now let's calculate the molar mass of Na2CO3. Sodium is 23 times what? 2 plus carbon, which is 12, plus oxygen is 16 times what? 3. We could always bracket this. 23 times 2 will give us 46 plus 12 plus 16 times 3 is 48. If you add very well, you have 106 gram per mole, which means that conc in gram per dm3 of Na2CO3 will now be equals to, conc in mole per dm3 has been calculated to be 0.0515 multiplied by the molar mass, which is 106. If you also punch your calculator very well, you have what? 0.0515, which is this value here as CB, multiplied by 106, the molar mass of Na.
5.45.
You have 5.4. 5 what?
9.
9.
5, 9.
So 3 significant figure is 5.46 in gram per dm3. In gram per dm3. Then BIV. percentage purity of what? Na2CO3. VIV, equation VIV, percentage purity of Na2CO3. In a percentage purity of Na2CO3 will now be equals to conc in gram per dm cube of Na2CO3 all over conc in gram per dm cube of mixture multiplied by 100/1. Conc in gram per dm cube of Na2CO3 is what we just calculated here, which is what? 5.46 all over. If you go back to the equation, you see that the word conc in gram per dm cube of the mixture is given as what? 8.00 multiplied by 100/1. Engage your calculator. 5.46 times 100 divided by 8. 5.46 times 100. You have 68.25%. 68.25%. Question BV. Percentage impurity in B. Percentage impurity. BV. Percentage impurity in B. Percentage impurity in B will be equal to, if you check the mixture given to you, you discover that it is only sodium trioxo carbonate 4 that are reacted. So sodium trioxo nitrate 5 only acts as what? Impurity. I think we jumped to the equation, right? Mass of what? NaNO3.
Yes.
Mass of NaNO3. That's V. The equation V is mass of NaNO3 in B. Okay. Recall that mass of Na2 as part of the mixture, Na2CO3 plus mass of NaNO3 is equal to what? 8.00 gram per dm cube. And we have calculated the mass of what? Sodium trioxocarbonate in gram per dm cube to be 5.46 gram per dm cube plus mass of what? Sodium trioxonitrate 5 is now equals to 8.00 gram per dm cube. To make the mass of sodium trioxonitrate 5 the subject of the formula, you have mass of NaNO3 is equals to 8.00 minus 5.46 all in gram per dm cube. If you subtract very well, you have what?
2.54.
2.54 gram per dm cube. 2.54 gram per dm cube. This is question VI. Question VI. VI. That is percentage impurity. percentage impurity in B. Percentage impurity in B. In B will now be equals to mass of the impurity, and the impurity is NaNO3 all over mass of mixture multiplied by 100 over 1. And mass of NaNO3 is what we just calculated as 2.54. And the mass of the mixture remains 8.00 multiplied by 100 over 1. Engage your calculator. 2.54 times 100 divided by 8. And you will have 31.75%. Of course, if you add 31.75% plus 68.25%, you could have 100%. Which means you could also calculate the percentage impurity by 100 minus 68.25%. You could also have the same answer. Then VI. This one says explain why NaNO3 did not take part in the reaction. Sodium trioxonitrate 5 as part of the mixture did not take part in the reaction because it is the what? The salt that come from the what? The strong base, which is sodium trioxonitrate what? 5 salt HNO3, which is given as the what? As the A. So the A HNO3 could only select what? Sodium trioxocarbonate and react, leaving NaNO3 as the what? As the impurity. Hope you like this video.
Yes, sir.
Comment, share, and follow Superstar School of Science for more of chemistry lessons. Thank you. I wish you success in all your exams. That is always our utmost priority. You have a wonderful day.